So critical points or stationary values, their stationary values mean the slope of the tangent is 0. So when we were doing our problems yesterday and we were putting those zeros on the line, those are stationary or critical points. So we've already done this, but we just didn't call them that. So we're just going to look a little more careful at those and what happens when we have patterns of positive, negative, negative to positive, and so on. Okay, I'm going to call those certain names. All right, so on our original graph, it's going to look like this. All right, so we're trying to find where these are slopes of 0, right? Because this was the change from increasing to decreasing, right? That was the whole purpose of finding these, because to one side it's going to be increasing, and to the other side it'll be decreasing. So if we find these values, we can find out when a function is increasing, when it's decreasing, when it's changing from increasing to decreasing by going through a small little part of the graph where it's actually equal to 0, which is between negative and positive. Right? So we're going to call these different names from now on, which you already are familiar. How about maximum and minimum? And there's going to be one more called points of inflection, which is probably new. So maximum, right? Maximum and minimum we're pretty familiar with. So what you're going to do, we're going to still solve those. So if we have something like this, of course, the point at the top is called the maximum, right? Right? And that's when you go from positive or increasing, right? Positive slopes, increasing slopes, to the left, and then to the right it goes to negative. So when we were doing the plus minuses yesterday, well, anytime it went from a plus to a minus, that was always a maximum. And we're going to start calling it that. So the questions in the book are going to say, describe the stationary values. That means, is it a min, is it a max, and so on. Okay? And then if we have something like this is called an absolute max, because it is the absolute largest value of f of x that there is for this graph. Now, if this graph kept on going like this, and then some other value over here was higher than this value, then this becomes what's called a relative max. So we can have a absolute max if it's the absolute highest or largest y value of the entire graph, or something that's relative, meaning it does go up, it does go down, but there's some other higher y value somewhere else on the graph. So it just varies. And same thing for minimum, right? We can call this a minimum right here, absolute minimum right here. It's the very lowest part of the graph. But if this continued and went like this, where there's a smaller somewhere down over here, then this right here becomes a relative minimum. Okay, and you'll notice it's kind of the opposite of this one, right? So to find a minimum, it's when the slopes go from negative to positive. So every single problem yesterday, if you look back at it, if it ever went negative positive, that was either a relative or absolute minimum. All right, so those are the two more obvious ones. Let's look at the newer one, point of inflection. So what is that? All right, so this occurred, I think, on a few of the problems yesterday, maybe one or two. So points of inflection occur when it goes like plus plus or minus minus. So if I drew a graph something like this, where it's increasing and then it goes to 0, and then increases again, and then maybe goes down, something like that. So that would be the critical point there, and then also right here, right? Because that's where it's 0. It's 0 right here, horizontal, it's 0 right here. But if you look at the signs, it's a positive slope, and then it's a positive again. So if you have the same sign in a row, it's not a min or a max, right? A max has to go up and come down. A minimum has to go down and come back up. So if it just goes up and then hits 0 and then goes up again, that's called an inflection point or point of inflection. And we can do the same thing, of course, if it's opening or decreasing initially, right? So we can go like this. Decreases, hits 0, decreases more, and then goes back up. So this would have a negative slope, or actually this would be the critical value. So with this, it goes negative, negative again, and then over here is positive. Goes back up. So if we have two of the same sign in a row, right here or right here, two positive, two negatives, then you get an inflection point. And the idea is that all this stuff eventually helps us graph these without having a graphing calculator or Desmos or something like that. So the more information we can get about all this, whether it's increasing and decreasing, whether you have a min, a max, inflection point, it makes graphing or at least estimating the graph a lot easier. All right, so we'll just practice a few of those and then let you on your way. Okay, so let's go to here. All right, so find the critical points of each function. That's what we did yesterday when we solved it, right? And we could also throw in, find out when it's increasing or decreasing. So on your quiz, when you do these problems, it's actually going to have yesterday's question and this question, right? It's going to say, where's it increasing, where's it decreasing? Say if they're a min, max, or point of inflection. And then we're going to do the second derivative next week, which is going to be something called concavity. So all those will be in one question. So let's start this off. First of all, it's not in a form that we can actually take the derivative of. So first of all, let's do that. Let's do that and get equals and distribute x to the fourth minus 4x to the third. And take that derivative so we can find out when it's increasing and decreasing. So we have 4x, right? Bring that 4 down. So we have a 4x, drop the degree down by 1. So it goes from 4 to 3. That's all you have to do each of these, each term. So 4 times 3 would be negative 12. X, drop the degree by 1. So it goes down to 2. And then solve that for 0. So this is finding those x-intercepts of the derivative. Anything above that line is increasing. Anything below that line is decreasing. And how do you suppose we solve this one? Factor out of 4x squared. We'll have x minus 3 left over. So those are our two factors. So we got two factors. And they multiply and equal 0, which means either or both equal 0. So we get x equals 0. And then, of course, x equals positive 3. All right, and now we can draw it out. So we have our critical values, 0 and 3. And what numbers do you want to pick? Some number between 0 and 3. So find f prime of 1. And something bigger than 3. Let's say 4. And something smaller than 0. Negative 1. And we're just looking to see what the signs are for each one of these, right? That will tell us if it's positive, that means it's increasing. If it's negative, it's decreasing. All right, so check out your calculator. And this one does have the evaluation if you want to use that, or you can just type it in. I like using the evaluation. So if I hit second on that, then I just have to type in my derivative function, 4x to the third minus 12x to the second. Very useful. Use this function, hit enter, and it'll ask you what numbers you want to plug in. So we're plugging in negative 1, 1, and 4. So I'll start with negative 1, and I get negative 16. That's negative. And then I just hit second and then start all over, right? But the last expression will still be there, so you don't have to retype it, which makes this really nice. So we want to do positive 1. Just take off the negative. And that gives us a negative 8. So we don't care about the number, we just care about the sign. And then lastly, we have 4, which is positive. So from here, right, we could say it's decreasing. Everything less than 3 is decreasing. So if we were doing yesterday's assignment, we'd say, we'd throw this on. Decreasing, right, x is less than 3. Increasing. Now, it won't ask you to do this on today's homework, but I'm just telling you on the quizzes, it's all going to be wrapped together. One equation, one derivative, and you'll find all these different values. Increasing, it's everything greater than 3. So the 0 doesn't really have any effect on the increasing or decreasing. Okay? We could say here x is less than 3, but with x not equal to 0, not equal to 0, because technically at 0, the slope is 0. It's not decreasing exactly at 0. Right? Or we could say everything less than 0 and then everything between 0 and 3. So that would be another way of writing it. Right? We could say x is less than 0 and x is between 0 and 3. So these mean the same thing. You can just play with which one you like better. And of course we have our set notation. You can use that as well. But the question now says describe the nature of each critical point. Right? So that's the new part. So for x equals 0, what kind of critical value is that? So it goes negative to negative. So that would be a inflection point. And then our other critical point, which is 3, would be a what? Goes from negative to positive. Yeah, so if you're going negative slope and then you have positive slope, that's a minimum, right? So we have a minimum. And don't worry about if it's a relative or an absolute. Because I think in the back of the book answers, it does say if it's an absolute min, but don't worry about that relative absolute part yet. We'll touch on that a little later. If you wanted the actual coordinate for this, we could plug these values back into the f of x, and that'll give us the actual coordinate of the inflection point or the minimum or maximum. But otherwise, just report at each critical point x equals and what that critical point is. Okay? So that is the process for one of these. So basically, most of this, until we got to right here, everything was reviewed from yesterday. This is the only little new part you're adding on to your answers moving on. You don't have to do this part with the increasing and decreasing, but if you just want a good practice, so you do really good on the quiz, go ahead and do that. All right, so try one on the other side. Flip it over. 12x minus 2x to the third. Try that on your own.